Okay, so welcome to section 7.3, which is musical scales. So musical scales. Okay, so definition. So a perfect number that's what we're defining, a perfect number. So is the sum of its proper divisors. Is pardon me. Is the sum of its proper divisors. Proper divisors. So for example, 6 has proper divisors 1, 2, and 3. And do you agree that 6 can be written as 1 plus 2 plus 3? So it's a proper number because that, of course, is 6. So check mark. Sorry, perfect number, not proper. But what I did want to, why I said proper, is because note, what is a proper divisor? So a proper divisor is all divisors other than the number itself. So for example, 6 goes into 6. It divides. 6 divided by 6, of course, is 1. But it's not a proper divisor. A proper divisor is anything less than the number itself. So that's what I mean by that. Okay, so definition. So a product perfect number. So a product means multiplication. Well, if I could spell it, product perfect number is analogous to a perfect number, only now instead of instead of adding the proper divisors, we're going to multiply them. So a product perfect number is equal to the product of his proper divisors. So is equal to the product, meaning the multiplication of its proper divisors. Proper divisors. Okay, so for example, once again, make sure that's a G versus a 6. So 6 has proper divisors 1, 2, and 3. So 1 goes into 6 one time, 2 goes into 6 3 times, and 3 goes into 6 twice. And you agree that 6 can be written as 1 times 2 times 3, which is indeed 6, so check mark. Okay, so that is what a perfect number and a product perfect number are. So 6 seems important. So this is where we introduce the Pythagorean epogdoon. So epsilon, pi, omicron, gamma, delta, omicron, omega. Oh, that's a terrible omega. Let me try to make it better. Omega, and nu. So this is epogdoon. Wow, EP, pardon me. Ep epsilon in English. So what did I have here? We have capital E for epsilon. So in English, that's E. I guess I could write it capital English. And then we have capital pi. So that's pi. In Greek is P in English. Then we have Omicron. In Greek, Omicron, which is R-O. And we're going to, yeah, okay, I'll just get to that bridge when I come to it. Gamma, G, so this is gamma. Gamma in Greek, which is a G in English. And then we have delta in Greek, which is D in English. Then we have omega in Greek, which can be kind of thought as a W in English. And last, we have nu in Greek, which is N in English. So nu is N, so epogdoan. Okay, so the Pythagorean epogdoan. And this actually, ogdoan, think of octave, because that's where we're going with this. So let's start off with the perfect number 6. 6, 7, let's see, 8. Are these evenly spaced? Hopefully they are. 10, 11, 12. Does that look like it's evenly spaced? Well, good enough for government work. Let me move it over just a tad to the left. Let's see, something like, maybe so. Okay. So, in musical scales, 6 to 6, a ratio of 6 to 6, which is really 1 to 1, is known as unison. So if I have two notes that are exactly the same, so 6, a ratio of 6 to 6, or 1 to 1, which reduces to 1 to 1, is unison. So this is called unison. Okay. So I'm going nowhere, right? From 6, I've gone nowhere. Now let's go from 6 to 12, shall we? So 6 to 12. So I'm doubling up. This is 1 to 2. Oh, shoot, 12, not 2. 6 to 12. So what I'm going to do is I'm going to go all the way to 12 from 6. So I'm going all the way here. I guess I don't need an arrow. But 6 to 12 is going to be the same as 1 to 2. And this is known as an octave. Octave, or in Greek, a diapason. Diapason. Okay, so how can I... Yeah, I think I'll just leave it like that for the time being. Now let's go, what color shall we use? I've used blue. Let's use, I don't know, green. Shall we use green? Let's go from 6 to 9 now. 6 to 9. Okay. But actually, before I do that, maybe I should note something. That the ratio of 1 to 2, 1 to 2, is up an octave. And a ratio of 2 to 1 is down an octave. Okay, so what do I mean by that? Let me move this down. Move this down here, maybe. Let's say I've got a string. Now, if I cut that string in half, let's see, 1, 2, 3, 4, 6, 7, of course. And if I have only this much of the string, I've gone up an octave. So half of the string So maybe I should write half of this string. That'll make more sense. So half of this string, 1/2 the string, is up an octave, and twice the string, or 2/1. 2/1 the string, meaning if I made the string twice as long, I'd be going down an octave in music. So if you play a stringed instrument, you'll know what I mean. Okay, now let's go to where I was with the 6 to 9. So now if we're going 6, the ratio of 6 to 9, so that reduces, 3 goes into 6 twice and into 9 3 times. So this is a ratio of 2 to 3, and this is called a perfect fifth. Perfect fifth, which in Greek is a diapente. Okay, so if I have a ratio of 2/3 the string, so let's look at our string. So 1, 2, 3, 4, 5, 6. So say this is my string, and so I break it into thirds, and if I now only have 2 out of 3, 2/3, oh, oops, 2/3 of the string, I've gone up, right? So this is up a fifth. Whereas if I have 3/2 the string, so it's longer now, it's 1.5 times as long, then the frequency goes down, so I go down a fifth. Okay, so I hope this is making sense to you guys. We're going to continue on. Let's now do 6 to 8. Okay, 6 to 8, what color should I use? I'll use, pardon me, pink. Shall I use pink? So going 6 to 8, maybe I'll use dark gold. I like that. Okay, so now let's go 6 to 8. So we have a ratio of 6 to 8 now. But of course 6 and 8 are both divisible by 2. So that's 3 to 4. And this is a perfect fourth. And in Greek that's a diatessaron or diatessaron. Okay, so that means if I have 3/4 the string. Okay, so let's look at that again. So let's say we have 1, 2, 3, 4. So this is my string. 1, 2, 3. So if I have 3/4 the length of my string, of course I'm going up. So this is going up a fourth. Whereas if I had 4/3 the length of my string, that's longer than 1. So the string, that's going to go down because it's now a lower frequency, down a fourth. Okay. Last but not least, I'll do this one in pink. Let's go from 8 to 9, shall we? So I just want to go between these two here. And that does not reduce, so 8 to 9. And that's a Pythagorean whole step. So a Pythagorean whole step. Otherwise known as a sesquioctavum. Sesquioctavum. Ecclesiastical, I could say octavum, but it depends on which Latin we're speaking here. Okay, sesquioctavum, and what do we have here? If I go 8/9 of a string, that's not quite one whole, so it's a fraction. So let's see, 8/9. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the whole length, 9 parts. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I'm going to do is I'm just going to take 8 out of the 9. So, boy, that's a terrible drawing there. But what this is going to do is go from like C to D on the scale, or from E, actually not E to F, that's a half step, but we'll get to that later. So C to D, D to E, F to G, G to A to B. We have to exclude E to F and B to C because those are half steps. Okay, so if I have 8/9 of the string, that's up a whole step. Whereas if I have 9/8 of the string, that's larger than 1. That's going to be a little bit lower frequency, so down a whole step. Okay, so let's note something. So note. If I first go up a fifth, actually maybe I should color code it. What was the fifth? The fifth was green, okay. So let's go up a fifth. And then, what was my fourth? My fourth was in yellow, okay. Then let's go down a fourth. What does this give us? That's going to give us, so up a fifth, so up in frequency, that means a shorter or a fractional of a string. Then down a fourth, that means my string gets longer. I go down in frequency, so that's going to be 4/3. You might say, okay, that's not getting me anywhere. But what do I have in the numerator? I have 8, and on the bottom I have 9. So this is up or down? It's up a whole step because it's a fraction. So with respect to the length of the string, that's up a whole step. So up a fifth, down a fourth, which would make sense. I'm going a bit higher than I am coming back down. So let's do it the opposite way. Let's go down a fifth. Then up a fourth. So if I'm going down a fifth, now I want longer than my string to be longer, so 3/2 is bigger than 1. If I'm going up a fourth, I want a fraction, so that's 3/4. So what do we get when we do that? We get 9/8, which is longer than the original string, so that's down a whole step with respect to the length of the string. Okay. So let's see, how much space do I have? So definition. So part 1. So the arithmetic mean, mean of course, same as average. The arithmetic mean of two numbers A and B. Numbers A and B. is given by well, hopefully everyone knows this. Should be a plus b divided by 2. Now let me actually just write this as a fraction like so. Right, because there's two numbers, I'm adding them together and dividing by the number of numbers. There's two numbers. So we know the arithmetic mean, but now I want to define the harmonic mean. And maybe I'll use a different color. Oops, okay, if it lets me. Let's go a little bit darker here. So the harmonic mean is given by where should I put it? 2 times AB over A plus B. So this is a bit different. This is kind of a strange entity here. Okay, so Plato's lambda is what I would like to do next. And do I have enough room? Yeah, hopefully. Okay, so Plato's lambda and don't worry, I will get back to those harmonic and arithmetic means in a moment. Okay, so what I'd like to do is I'd like to have some sort of lambda, which is actually a triangular thing, kind of like, well, not drawn very well, like so. Let's see. So let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think maybe that's going to be equivalent. Yeah, something like that. Okay, so hopefully that looks okay. And this thing goes on actually forever downwards. But what we do is like we did with the octave. What color did I start with? Blue. So I'm going to have a 6 up here and a 6 up here. Okay. So now I'm going to go up an octave from 6. And if I go up an octave from 6, do you agree I get 12? Because I'm doubling. So let's go up an octave. Or actually, before I do that, let me write the numbers on the inside of this. So we start with a 1 on top. And then let's do 2. Let's double it. What's 2 times 2? It's 4. Let's double that. What's 2 times 4 is 8, etc. And on the right hand side, let's do the same thing, but let's triple. So 3 times 3 is 9. 9 times 3 is 27. Wondering if I should give myself more room. Maybe I'll make this a bit larger just to have more room to play with. But I think you get the idea. Nope, okay, why is that not working? No, it really does not want to. Okay, fine, maybe I'm just going to leave it like that. Okay, so like I was saying about the octave on the left, what's 2 times 6 on the left? 12. What's 4 times 6 on the left? 24. What's 8 times 6 on the left? Well, that's 48. Okay. So it's like I'm doubling each time. Let me go ahead and bring this 6 down a bit, so it looks more in line. Now on the right, I'm going to triple. So on the right, let's see, what color should I use on the right? Let's use purple, dark purple. Okay, so 6 times 3 is 18. 6 times 9 is 54. 6 times 27, well, instead of doing that, I'm just going to say 54 times 3. Well, 50 times 3 is 150, and 4 times 3 is 12. So 150 plus 12 is 162. So that's actually 27 times 6, hopefully, if I did the math right. Okay. Okay, so now what I'd like to do is I'd like to calculate the arithmetic mean and the harmonic mean. So what I'm going to do is I'm going to color code. So let's do the arithmetic mean. Arithmetic mean. On the left in yellow. Okay, so the arithmetic mean between 6 and 12. So I add 6 to 12. So what do we get? We get 18 divided by 2 is 9. So that's the arithmetic mean there. And actually, maybe I should have put circles around these guys, because they're the important ones. Okay, maybe not. And the 6 as well. Okay, so now let's do the arithmetic mean between 12 and 24. So 24 plus 12 is 36, divided by 2 is 18. I'm going to make that a bit better, 18. That's interesting. Okay, it looks like 9 times 2 is 18, but let's see if that works for the next one. The arithmetic mean between 24 and 48. So 48 plus 20 would be 68, plus 4 is 72, divided by 2 is 36. Oh, that's interesting, because 2 times 18 is 36. Okay, interesting. It's like down the left-hand side, what we're doing is we're multiplying by 2 down the left-hand side. Well, let's see if that's true for the right-hand side. So let's do the arithmetic mean on the right-hand side. Arithmetic mean in orange on the right-hand side. Okay, so let me circle these important guys. Why does it not want to do a circle? Okay, circle, circle, and circle, or an ellipse. Okay. So the arithmetic mean between 6 and 18, so that's 24 divided by 2 is 12. Okay. The arithmetic mean between 18 and 54, so if I were to add 20 to 54, I'd get 74. But I'm adding 18, so I only have 72 divided by 2 is 36, which interestingly enough is 3 times 12. Okay. I bet that 3 times 36 is going to be the next arithmetic mean. So if I add 54 to 162, well, if I had 16 plus 5, that's 221, so that'd be 210. But I have 4 and 2, so 216. 216 divided by 2 is 108, and that is indeed 3 times 36. Interesting. So I'm multiplying by 3 on the right and by 2 on the left. So now let's continue on to the harmonic mean. Harmonic mean. So the harmonic mean, let's analyze the first 2 numbers. So that would be 2 times the 2 numbers, which in this case are 6 and 12, divided by their sum. So 6 plus 12. Okay, so what do we have? So we have 2 times 6. I'm just going to leave this for a moment, times 12, because maybe I can cross cancel something. 6 plus 12 is 18, which is 6 times 3. So yes, I can reduce. So I know 6 goes into 6, that'll reduce. And I know that 3 goes into 12 4 times. So I end up with 2 times 4, right? 2 times 4, or 8. Okay, so the first harmonic mean on the left is 8. And without further ado, do you agree that on the left I'm just doubling? So I claim this will be 16, this will be 32, etc. So those are the harmonic means. Now it's interesting, well, maybe I'll leave that for a moment. So the next harmonic mean, if I were to double 32, I would get, what, 64? So that would be what was here if I cared to continue on. Why not? Go ahead and put it there. And what's 36 times 2? It's 72, so I could have gone on with that as well. Okay, let's do the harmonic mean on the right as well. What color should I use? Okay, so harmonic mean. Ugh, I don't really like this green, but that's okay. Okay, so for the first two guys on the right, now it's going to be twice the product of the first and the second, which once again is 6, but this time and 18. Okay, so if I leave this as 2 times 6 times 18, copy, paste, divided by 6 plus 18 is 24, which is really 6 times 4. So the 6 is reduced, and 4 does not go into 18. However, 2 goes into 4 twice, and then 2 goes into 18 9 times. So I actually get that the harmonic mean, the first harmonic mean, on the right is 9. And without further ado, I bet I just triple each of the subsequent terms. Right, etc. Okay. So I said I wanted to show you something else. Actually, let me move this a bit over. I need a bit more room. Something like that. Okay, so let's look at 9. 9 I know is 3 squared, right? Actually, let's do that in the other color. So this is 3 squared. This is 3 cubed. This is 3 to the 4th, right? Because I'm tripling each time. Well, on the left, 8 is 2 cubed. 16 is 2 to the 4th. 32 is 2 to the 5th. Oh, why did I choose to... I keep on using the wrong colors. Let me make this hot pink. So the harmonic means are powers of 2 and 3 on either side. Okay, so this I guess would be 2 to the 6th. And it is indeed. Okay, so now what did I say about going from 1 to 2? This was the octave, right? So let me write that, octave. But remember the ratio 2 to 3. Let's see. 2 to 3, which is in green, was a perfect fifth. So perfect fifth. And then the ratio from 3 to 4, well, that was a perfect fourth. 3 to 4. This is a fourth. Then we had, in pink, a ratio of 8 to 9, which is a whole staff. Ratio of 8 to 9. So what's interesting is that this little construction here has a whole bunch of things hidden within it. So this is an interesting little kind of game of math, but it produces a lot. So anyways, moving on. The final definition in this section is the circle of fifths. So the circle of fifths and hopefully some of you play music. Okay, so it's a range of 7 octaves. So it is a range of 7 octaves. Pardon me. 7 octaves. So maybe you play piano or otherwise know about that. And it covers all 12 notes. So the white keys and the black keys, right? So covering all 12 notes. All 12 notes of a musical scale. It's terrible. Of a musical scale. So, let me put a note. How does this work? We either increase or decrease our starting note by a fifth, right? So we start usually with A, and increase / decrease by a fifth until all notes are arrived at. Okay, so what do I mean by notes? I think it's easiest to see this on a piano scale. So let's consider, for those of you, I'm sure you've seen a piano, but I'm going to draw it because each time I try to open GarageBand, it doesn't work. Okay. So we usually have what's called the white keys. Maybe I'll make them so, that might be a bit too. So 1, 2, so C, D, E, F, G, A, B, and so this is C, D, E, F, G, A, B, and then we have the sharps, flats and sharps. So something like so. So that'd be C sharp or D flat. Well, it's supposed to autocorrect a bit better. No. So let's see if I can make this a bit straighter. There we go. This would be E flat or D sharp, though I've never really heard of D sharp. It's more often just E flat. So then we go to F sharp. Suppose you could call it G flat, but don't really hear that very often either. Then we have G sharp or A flat. we have B flat or A sharp. Okay. That's interesting. Well, let me go ahead and put a full octave, so the next C. Okay, so how many do we have here? We have 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, and 12. So there are definitely 12 notes in a scale, or an octave, before we arrive back at C. Okay, so I guess I didn't really need this here, but okay. So let's go ahead and create that octave using frequencies now. So example, let's create the circle of fifths. The circle of fifths fifths, beginning with A 432. So beginning. Is it 2 G's? Oh my goodness. No, I think it's 2 N's. Beginning with A at 432 hertz. And a hertz is a means 1/seconds. So the string will vibrate at 432 beats per second, basically. Okay, so let's start with A 432. Oh, before that, let me note. So note an increase in frequency is a higher note. Hence, the opposite to an increase in string length. So to increase the frequency, we want to multiply it by something larger than 1. So if I start with A at 432 hertz, and I want to go up a fifth, so let's have my fifth be, what color was my fifth in? My perfect fifth was green. Oh boy, I really don't like green. Let's just use the perfect fifth being blue, shall we? So I'm going to go up 3/2, because 3/2 is a fifth, and that's with respect to frequency. Okay, so if I divide 432 by 2, I get 216. Then I multiply that by 3, and I get 648 hertz. And that turns out to be an E. So I've gone up from A to E. So now let's go ahead and multiply E at 648 hertz. Let's move that up a fifth. Okay, so I divide that by, what color should I use? If I divide 648 by 2, I get 324. Multiplying that by 3, I get 972 hertz. And 972 is a B. So now I'm at a B, 972 hertz. pardon me, 972 hertz. And now I want to go up another fifth. So 3 over 2. So what does that give me? Well, 2 into 972 is going to be what? Well, half of 900 is 450, and half of 72 is 36. So 450 plus 36 will be 486. And if I multiply that by 3, I get 1458 hertz, which is approximately an F sharp. Okay, so now let's start with my F sharp. Add 1458 hertz, and let's go up a fifth again. So 3 over 2. Okay, so what do we get when we do that? We get 2187 hertz, which is approximately a C sharp. So now from a C sharp at 2187 hertz, let's go up another fifth. So remember, I have to do this 12 times to get through to each of the 12 notes, right? 12 notes here. So I've got, I should mark them off, shouldn't I? We've got, well, I'll do that afterwards. Okay, so what do I have here? This gives me 3,280.5 hertz. Now the issue here is the decimals. I'm trying to avoid those, so you'll see what I'm going to do in a moment. So this is a G sharp. I'll do one more going upwards, so G sharp at 3280.5 hertz. Let's go up one more fifth in this direction. 3 halves. So that's going to get us to, okay, 4,920.75 hertz. And that is an E flat. Okay, so what do we have so far? We have an A. We've got an A. We've got an E. We've got a B. We've got an F sharp. We've got a C sharp. We've got a G sharp. And we've got an E flat. Okay, so we've got a lot of them, right? But we still have C, D, F, G, and B flat. Okay, so what I'm going to do is I'm going to start again with A 432. But what I'm going to do this time is I'm going to go down a fifth instead of up. So to go down a fifth, I multiply by 2 over 3. Okay, so in this case, what color should I use? Let's use hot pink, shall we? Oh, that's not hot pink. Okay, so in this case, when I go down, I actually get 288 hertz, which is a D. So I've got 288 hertz, a D at 288 hertz. And I'm going to go down a fifth. So I'm going to multiply by 2/3. So what that's going to get me, it really doesn't look different enough. It's darker. How about this one? Oh boy, I've already used all these colors. What do I do? This is a bit darker. Okay, so if I go down 2/3 from 288, I got 192 hertz, which is a G. Okay, so I've got my G now. I've got my D, which was in hot pink. Okay, so let's start at G with 192 hertz. And once again, I'm going to go down a fifth, so 2/3 from there. So what that's going to give me then is going to be 128 hertz, which is a C. Okay, so now I've got my C. So now I've got C at 128 hertz. And I want to go down a fifth, so 2/3. So what do I get? What I get then is 85.333. So hertz, which is an F. There's my F. Got that. Looks like the next one should be B flat, and then I'll be done. Okay, so I've got my F at 85.3 bar hertz. And I'm going to finally go down. At this point, you wouldn't be able to hear it. These are pretty low, but you get the idea. Okay, let's have it be green. Do I have a green? Oh, yes, I do, but let's have it be olive green then. So finally, going down the last gives us 56.8 bar hertz for my B flat, indeed. Okay, B flat. I did it. So this from 56.8 hertz to 4,920 hertz is a range of 7 octaves, and by multiplying by fifths, either going up or down, we have covered all 12 of the musical scale. I'll see you again in the next section.